More review solutions for the midterm. So based, number 28 here, based on the marks you see in triangle MTH, what is HA? So what we're looking at here is these marks indicate that this A is the midpoint. That's one way. So HA could be the median. We don't know about the right angle here, so let's assume it's not the perpendicular bisector, but the marks are showing it's a median because it hits the vertex to the midpoint of the other side. Okay, so density, this goes back to the first chapter. We all do these differently, so I want to make sure that I explain this. So 752 kilograms per cubic meter. I like to convert that into 752 kilograms over 1 cubic meter, 1 meter cubed. Next, the circumference of the tree. Okay, so let's say we were looking, right at the bottom if we were to slice through it. Okay, it'd be a circle. That circumference is 4.5 meters. Okay, now we'll look at the trunk. Let's imagine it was a cylinder. That's the closest shape, the height of which is 8. Okay, so what we're going to do is we're going to have to get the volume. If we can get the volume of this cylinder, we will be able to then use the density that's given here to calculate that. So volume of a cylinder, look it up. It's a formula that's going to be on our formula sheet. Circumference is also going to be used. All right, so I'll have to use that first. One formula that circumference gives is 2 pi r. The other one's pi r squared. Okay, right there. So 2 times pi times missing radius. Be careful on this one. Use the big fraction feature on your Inspire, or you could separate it or put parentheses around it, either way. The calculator gives me 0.716 and a whole bunch of stuff after. The reason I'm putting that ... is I should not round yet. We do not want to round until the last step. Now this radius that I found from the circumference, that is going to be, that's going to be the radius I use on this cylinder. So let's go back to this formula. Sub in that number of 0.716, whatever else, squared times the height of 8. Double check something here. Everything's been in meters. Make sure units of measure are identical in everything. Otherwise, we got to convert and make sure we're careful there. Okay. So I'll let the calculator do the work here. And we get 12.8916. Again, leave that in the calculator. Continuing on, we'll have to apply the concept of density. I like to reuse this conversion here. 752 kilograms for every 1 meter cubed. This volume is meters cubed, so I try to coordinate here. Since meters cubed is on the bottom, I'm going to put meters cubed on the bottom as well on this fraction. And I will put X there to represent the kilograms. Cross multiply, and let's ignore, I know this isn't great, but let's ignore the units of measure just for a minute here. Okay, so it's 752 times that 12.8916 gives us. And that is 9694.45. It did say approximate. Is that hopefully close? Yep, it looks like choice 2 is going to get that done for us. So another one from the volume chapter. Okay, these are familiar ones. We just completed these recently, but we'll of course do those again. Area. What we've got to be really careful of with this particular problem is that there's no perpendicular sides, so there's no right angle in this triangle. For base and height, if we want to use this formula, 1/2 base times height, the base and height have to form a right angle. There is no side that we have that's an easy right angle to work with. So instead of trying to do that, I'm going to use the box it in method. Okay, so we're going to use box method around this one, and it's going to be much more efficient to do it this way. So I always put the numbers right on the diagram for every side and every rise and run, so to speak, that we use. I think that's what we need to do to show work. Okay. What we have now is we've got the area of the box. It's a rectangle. Dimensions are 4 by 2. The word dimensions just means length, width, height, whatever. I'm going to call this triangle A, triangle B, and triangle C. We're going to cut those away. So the area of triangle A is 1/2 times 2 times 1. Area of triangle B, 1/2 times 3 times 1. Yes, that's a decimal. That does happen. Area of triangle C, 1/2 times 4 times 1. I usually add those together, 4.5, and then the area of the triangle in the figure that we're looking for, that's 8 minus 4.5, which is 3.5. Okay, so that's our area. Last chapter they wanted perimeter, but they didn't ask for that here, so we'll just do that. That's it. Okay, for this one, the most efficient area method would be to, I think, split this. You've got a nice rectangle here. You could use trapezoid formula, because it really has 2 parallel sides. I'm just going to split it up, though. It's just much more efficient. I've got 2 across. I've got a rectangle with 2 and 1 as its dimensions. I got a triangle with 1 and 2 as its dimensions. So I'm going to do that. The area of the rectangle is 1 times 2. Area of the triangle is 1/2 times 1 times 2. So the area of the figure is 2 plus 1 is 3. Oops. So that's what it looks like. All right. Volume of this figure to the nearest hundredth. So, okay. What we have is we have to realize we have a cone and a cylinder combined. So we have to first recognize that. We're going to end up with 2 different formulas that we're going to use. So look at your formula sheet. Volume of a cone is 1/3 pi r squared h. Volume of the cylinder is just pi r squared h. The dimensions for r are 2, so 2 squared. I think they're tricking us on this one. It looks to me like the 7 is the slant height. Okay, so I should have calculated that first, meaning I've got to get the regular height, the height that makes the right angle with the radius. So I got to hold off. That height is not calculated yet. I have to do that. What we're going to use is Pythagorean theorem. 8 squared plus 2 squared equals 7 squared. So then that's, there's other ways to set this up, but this is how I like to do it. Oops, it's just 45. Now the process is I'm going to take the square root of both sides. That's how you get rid of the squared. Right, inverse operations. Okay, so that's a little under 7. I'm not going to round that yet because we shouldn't round in the middle of a problem anyway. So I'm just going to put it as the height is just square root of 45. So I'm going to replace h with that. Let the calculator do this, and it does say nearest hundredth, but we won't round till the end till we put them together. Calculator is telling me 28.0993. All right, now this one has a different height. So just understand that. This is the height of the cone, the square root of 45 here. But the height of the cylinder, new problem, is actually 5. Now that doesn't look like the height, but really what the height is the distance, the perpendicular distance between the bases of that cylinder. So believe it or not, the height for the cylinder is actually 5. The radius stayed the same, so this is all we've got to do. Again, we'll let the calculator do this work. And 62.8319 is what it looks like. Yeah, that's accurate. Total area, or total volume, is going to be, add those two. And then that is when we will apply our rounding. 90.9311. It wants hundredth. That's 2 places. Okay, there we go. Good. And what else did they want here? Circle all that could be cross sections. Oh, I see. So when we take a cross section, what we're doing is we are taking a flat surface and cutting through the solid. The face that we expose, that we cut through, once we open it up, the 2D face that cuts through from the figure is what we call the cross section. Now, if we were to take just a cylinder, okay, just the cylinder, I'm sorry, just the, if we were to take just the cone, we could get a triangle with a cross section going this way. Okay, we could do that, all right? But because this figure, if we cross section straight down through that way, that isn't going to quite be, yeah, that figure's not, that figure's going to be a pentagon if we cut through. So I am going to have to eliminate, I can't see any way to get a triangle. A rectangle, again, I don't see any way to do that. Yeah, no, if we cut through that way, I don't know if we cut through diagonally this way, if that's going to possibly do it. I'm just not seeing it. Yeah, I'm not seeing any rectangles. Circle for sure. If we cut this way, we're going to, parallel to the bases there, we are going to find a circle. So that one's for sure. An ellipse can be found by going, cutting diagonally a little bit through a cylinder. Okay, so if we have this cylinder, we cut diagonally, it's going to elongate that circle. So I like that as an option. I couldn't find a rectangle. I really don't think I'm going to be able to find a square. I do believe cutting right down through the middle is going to find me a pentagon, though. So looks like those are my cross sections that I could potentially see. Okay, so number 32, sequence of transformations that will map the figure on the left to the figure on the right. So we've got to be really cautious here, making sure that we map the correct one that's being asked for. All right, so what I'm seeing on this figure, it is, it's going to be quad, let's see, we're going to try to map quad QRST onto what it looks like is Q should match U. So Q should go to U is what it looks like to me. R looks like it should go to V, S to W. I'm guessing that from the look of the angles. So, and then of course the sides, you've got to make sure that corresponding parts match up. And it looks to me like T and X are corresponding. So we got to find a way to map Q to U, R to V, S to W, and so forth. So what I check first is I always check orientation. Okay, that will tell me if a line reflection was used or not. So I circle and I start at Q and I move to R. That is in a clockwise direction. Then I go to quad UV WX. I start at U, I move to V, then to W, then to X. It's going that way, also clockwise. All right, so here's what that tells me. I won't need an odd number of line reflections because an odd number would switch orientation. These have the same orientation. So I think I'm going to do it either with a translation or possibly a rotation or both. All right, so let's get rid of that. We eliminated a single line reflection. So, all right, next thing I'm going to do is I'm going to look at this. If S has to map to W, does this here form an angle? Yeah, that looks good. Okay, 1, 2, 3, 4, 1. The Horizon runner 1 and 4. Horizon 1 run switched. So this one here has a slope that's negative 1/4. Yeah, this one has a slope that's 4/1. If that holds true for all the points, which I think it does, yeah, they have slopes that are going to be negative reciprocal. So if I map Q to the origin over to U, that's going to make a 90-degree angle. So is S to the origin to W. I'm pretty confident that that's going to be the way to go here for all of them. So, all right, what I'm going to do is a sequence of transformations for this one. I'll get some space here. All right, I'm going to satisfy part A. I guess not. So for this one, part A, I would rotate the quad QRST 90 to negative 90 actually. That way is negative. Negative 90 degrees centered at the origin to map onto UVWX. Okay? So that's this one. What transformation would map the figure on the left to the figure on the right? That takes care of that one. Make sure it's negative 90. You've got to give the angle and the center when we're on the graph paper. So we want specifics, okay? We want specifics off the graph paper, but especially on the graph paper. We should be able to talk about specifics here. The second one, to map one onto the other, again, I would, I'm kind of in my head, I'm checking orientation, and what I'm seeing right now is that this angle D must match R, because this side SP matches BC. Okay, so, and it looks to me like A should match M. We can trust the look of the diagram a little bit more on a graph than we can in the synthetic problems, which are off the graph. So it looks to me like the orientation is reversed. That means a line reflection is appropriate. What I'm going to pick for this one, okay, for this choice 2, all right, I'll get some more room here. So for the second one, what it looks to me like is that I'm going to reflect, it's a quadrilateral again, A, B, C, D. Over the x-axis. Now I'm just doing that to fix orientation. What I mean by fix it is to get them the same. Reflecting will change this image, or this pre-image's orientation. And if I'm going to do this, I'm going to actually show it. So that's like the appropriate work that's necessary. Okay. So this would be, careful here, B primes, nope, I mixed that up. You want B prime here, C prime here, B prime here, this is A prime, and this is D prime. Now, from there, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 10, 11 to the right, and 2 down. So that's move number 1. Reflect over the x-axis to map to quad A prime, B prime, C prime, D prime. Then translate quad A prime, B prime, C prime, D prime. Right 11, down 2 to map onto. And that is going to be, make sure we match them, it's going to be MPSR. MPSR. Okay, I realize this is a long video. I try to stick to 10 minutes. Sorry about that. So I'll put the rest on the next one.